MathClass101.com, Algebra, Solving Quadratic Equations by Completing the Square. Copyright 2007 by InternetClass101.com. As I mentioned in the last video, the other method for solving a quadratic equation is called completing the square. And again, I think the best way for me to demonstrate this is through example. And so let's again start off with an equation. Let's say if you had the quadratic equation x squared plus 6x plus 2 equals 0. And you wanted to solve that quadratic equation. Well, we showed earlier how you can use factoring, but there's another method. And instead of going through the steps and using a bunch of symbols, I'll just go through this example and talk you through it and explain why I'm doing what I'm going to do. But before I do that, I want to remind you something or point something out to you before I go any further. And it's simply this. If I had this term, and again, put this on hold just for a second. Just because I'm writing this below it doesn't mean there's any connection. Keep that in mind. If I had this, x plus a squared, what is that? Well, if we took the time to actually multiply that all out and simplify it down, we would get x squared plus 2ax plus a squared. And the reason I take the time to show this to you or remind you of this is what we're about to do, the manipulation I'm about to do, is the goal is to get it in the left side of the equation into this form. So keep that in mind. Our goal is to get the left side of this equation in this form. That's all I'm going to say for now. So back to our problem at hand. What I would like to do, if you don't mind, is I'm going to move this 2 to the other side. I'm going to subtract 2 from both sides. Well, if I subtract 2 from this side, that goes away. And I'm just left, I'm going to draw an arrow to remind you that this is a separate little note. Left with x squared plus 6x minus 2, that goes away, equals 0 minus 2 is negative 2. Now, I subtracted 2 from both sides, so this equality still holds. I haven't violated anything. Now, what I'm about to do, the purpose of what I'm about to do is to let me get this form. And without a lot of explanation, I would just like to do it, and after I've done it, it will kind of make sense what I was doing. Allow me to take half of this constant, the constant in front of x, which is 3, half of 6 is 3, and square that. What is 3 squared, or 3 times 3? That's 9. Just for the moment, allow me to add 9 now to both sides. Okay, a moment ago you allowed me to subtract 2 from both sides. Allow me now to take half of this constant in front of the x, which is 3, square it, which is 9, and add that to both sides. Bear with me just for a little while and it'll all make sense. So I've taken half of 6, which is 3, and I've squared it, and I've added that to both sides. 3 squared is 9. Negative 2 plus a positive 9 is 7. Again, I have not violated the equation. We still have everything is still okay. Well, what is 6? 6 is 2 times 3. What is this? 9. 9 is 3 times 3. If we look up here, here's a 2, there's a 2. There's something squared. 3 times 3 is just 3 squared. Well, what can we say then? Let's call the 3 here what's a up here. If we do that, then this side of the equation at the top here is exactly what we have here if we replace a with 3. If I let this a equal 3, if I let this 3 be the a in the equation above, then this is exactly this. Now that we know that, I can, based on what we wrote here and showed here, and you can actually multiply it out and simplify it and show it, I can then rewrite this left side as x plus our a, which is 3, squared equals 7. I haven't violated the equation because all I've done is replace this side of this equality here with the other side. I'm allowed to do that. You can replace an equivalent with a form of an equation. Well, what do we have here? We have a term in parentheses squared equals a constant. What's one way to go about solving that? Well, take the square root of both sides. If we take the square root of both sides, the square root of something squared is just whatever was in the parentheses, so that's just x plus 3. If we take the square root of 7, we get the square root of 7. But we get the plus or minus square root of 7, right? If you review back on taking the square roots of a constant, you get a plus and minus square root. So just as before, we have two roots, or two terms. We have x plus 3 equals a positive square root of 7, and we have an x plus 3 equals a negative square root of 7. Anytime you have a quadratic equation which the highest power is 2, you're always going to end up with two roots. That's why if you're ever taking a test and you're solving a quadratic equation and you get ahead of yourself, if you only end up with one root, remind yourself, wait, I'm supposed to have two roots. Aha, square roots always have plus or minus. And that will remind you if you ever forget, and you will forget, everyone does. So then all we have to do is move each of these over. Minus 3 on both sides gives us plus square root of 7 minus 3. And then moving the 3 over here gives us negative square root of 7 minus 3. And since these are both constants, I won't actually use a calculator to tell you what that is. I'll just stop here. But we've solved the problem. This is a constant, and this is a constant. So we have found the two possible roots for this equation using this quadratic equation, I should say, using the method of completing the squares. Now that we've done so, I would like to come back up here to the top and go through with you again the method we used. We started off with some general quadratic equation. We reminded ourselves of this, that if you have x plus some constant squared, you can expand it to this form. And if you use this form with the 2 and the a squared, to take advantage of that, I took this constant in front of the x and I cut it in half, which was 3. I let half of this constant be my a. So half of 6 is 3. So I set my a to 3. This gave me the form 2 times a times x, which is this term. That's why I did that. I then added that to both sides. 3 squared is 9. My a was 3. A squared is my a squared there. I then added that to both sides, which took this negative 2 and turned it into a positive 7. 9 minus 2. I then replaced this form on this side of this equality with the equivalent form on the other side, which I'm allowed to do. I then took the square root of this equation, which gave me this, and I then took the fact that a square root, when you take a square root of an equation, you get a plus and minus possibility on the square root, which gave me my two roots. And that is how you use the method of completing the square to solve a quadratic equation.